All right, here we go. Let's take a look at the next section. We're going to talk unit circle and radians. This is pretty awesome. I'm pretty fired up. I'm actually making this video on Pi Day, and there's a lot of pi in this. We got, in case you didn't realize that, let's go back to that. That is a unit circle. Get it? Unit circle. See what I did there? There's the real unit circle, and that's what we're heading towards today, which is going to be awesome. And because it is Pi Day, and there's going to be pie in our unit circle, I think of my favorite pie, oatmeal cream pie. So good. I'm going to have to go eat a couple after this. They're amazing. Little known fact about Little Debbie there. Remember Little Debbie? That's the theme. Before Little Debbie, they actually were going to try out this Little Kelly. Not quite as adorable as the original Little Debbie. Didn't go well. No one wanted to buy desserts from Little Kelly. So they switched it back to Little Debbie. Let's get this going. So we are going to look at approximate versus exact values today. So we've been kind of chilling with these trig functions here, and we can find the sine of 60. At this point, I know you guys are pretty good at this. We can just type in our calculator. What is the sine of 60? Calculator is going to tell us this really crazy long decimal here. I'll even bring it over to our screen here and make sure we have it. So the sine of 60 is 0.8660254. That's a great decimal. It's to 8 places, but that's actually cut off here. The calculator would like to keep going, but it can't. It only shows like 8 or 9 decimal places here. So this is approximate. So when we do the sine of 60, we always say something like this. It's approximately 0.86 or 0.866. That's a rounded value. Now, yes, it's really, really, really good. And like it would work for most things, but today we're going to talk about exact values. We want to find some exact, non-rounded, non-calculator values for this. Well, how in the world are we going to do that? We're going to go back to geometry, a little old school here. A little shout out to Geo. And we're going to do special right triangles. This is going to help us find the exact values in some not using the calculator answers here. So check it out. Quick review. Hopefully this jogs your memory. If not, you may have to go back and watch some geometry videos. 30, 60, 90 triangle. Do you remember it? Well, check it out. Draw a little right triangle. I hope yours is more right than mine. It's a little slanted there. So this is 30, 60, 90. So these are special triangles. Why are they so special? Well, it's awesome. If you take the smallest angle on the smallest side, let's pretend this was like 5. Oh my gosh, that is a terrible looking 5. Let's try that again. If this is like 5 feet, let's say, that's the shortest side because it's across from the shortest angle. Well, then the longest side across from my hypotenuse is always double, so this would be 10. And then the medium side would be 5 times radical 3. We just know that happens. So if you know one side, you can find all the sides. Let's do that again. So if I had this one, 30, 60, 90 again, so there's the 30, there's a 60, there's a 90. If this is 3, what is the long side? It's double it, it's 6. What is the middle side? It is 3 radical 3. Always true, always works. So if you break down the rule, like if you ever had a rule for this, and if I go, let me put my 30, it only works for 30, 60, 90. I can fill in the missing side. So I always start with the short side. Always try to find the short side. If this is 1, the longest side is double that. It's 2. And then the other side is radical 3, square root of 3, or it's 1 times the square root of 3. So this is what we need to know. This is what we need to have. If this is not jogging your memory, go back to our geometry. I think it's chapter 7. You can check out a full-on explanation of why that works. So good, we're tying in. The other special triangle, do you remember it? Is a 45, 45, 90. So there's 2 types. These are going to hook us up with some exact values. So let's quick refresh what is 45, 45, 90. Well, this one's super cool because if these angles are the same, 45 and 45, then these sides are the same. So if this would have been 5, yeah, the other side also has to be 5 because they're the same side across from the angles. They're the same. And then what's the hypotenuse? You times it by radical 2. Fantastic. Just to make sure we got it, if I do another one here, if this is a 45, 45, 90, and sometimes maybe I'll give you this side as like 7 radical 2 or something. If this is 7 radical 2, you could tell me the sides are 7 and 7. They have to be the same, and that's times radical 2. So what is the rule we need for that? The rule is if I have a 45, 45, 90, 45, 45, 90, and this is what I want you to write down, circle it. If this side is 1, this side is 1, this side is 1 times radical 2. So we're going to use that. Hopefully you have some experience with that. If not, refresh it. And what are we going to do with that? Well, now I can find exact values. So check it out. If I want to find the sine of 60, well, check it out. Here's a 60-degree angle right here, the sine of 60. Well, what is sine? It is opposite over hypotenuse. So really the sine of 60, in this case with these special right triangles, is what? It's radical 3 over 2. We may be thinking, what if I picked one of these triangles? Well, check it out. What is the opposite over hypotenuse in this case? It's the sine of 60 is radical 3 over 3 over 6. Well, what happens here? Boom, these cancel. And what are you left with? Well, you're left with radical 3 over 2. It goes in there once, goes in there twice, so it's radical 3 over 2. So it doesn't matter which triangle you pick, the sine of 60 is radical 3 over 2. This now is an exact value. I didn't put in my calculator and round it. Do you believe me? Let's make sure we're right. Before we get too far, let's make sure it's right. Check it out here. I can say, what is the square root of 3 divided by 2? If I'm right, it should be the same decimal, yeah? Boom. Check it. There it is. It is the same decimal. So this is legit. So now I don't have to do calculator rounding or approximate. This is the exact value. Some of you calculator savvy people were like, well, Mr. Bruss, couldn't I just math frac that? Try it. Go ahead and try it. Math frac it. Doesn't work because it can't handle the square root. Sorry, man. Can't handle the radicals. So you're actually going to have to do these by hand. So these are exact values. That's our goal today. And the thing is, there's not too many of them. You only have to know 30, 60, 90, and 45, 45, 90. All right. So if we're going to find the exact value, cosine of 30, so what I'd like to do is you can just draw the cosine of 30 like we just did it, right? You can just say, hey, here's a 30, 60, 90. I know the short side is 1. It's easy. Make up any number, but 1 is the easiest. Double it. Times it by radical 3 medium. There it is. So now using that triangle, what's the cosine of 30? Well, cosine is adjacent over hypotenuse, so it's radical 3 over 2. Awesome. How about 45? You could just draw a 45, 45, 90 triangle. So there's only there's only 2 triangles we can draw. 45, 45, 90 with sides of what? 1, 1, radical 2. And I want to find the sine of it, so that is what? Does it matter which angle? Nope. It is going to be opposite over hypotenuse, so it's going to be opposite over hypotenuse. So this is good. This is right. It's not simplified, though. So you do have to clean this up a little bit. So how to clean it up? Well, I can't leave a square root on the bottom, so I'm going to multiply that by the square root of 2. Whatever you do to the bottom, you got to do it to the top. That keeps it an equal fraction. So square root of 2 times square root of 2 is 2, or the square root of 4, which is 2, and then 1 times that. So that one you have to do a little work for. So sorry about that. Every now and then you'll have to simplify the denominator. We can't leave that in there. So the sine of 45 is really this. How about the tangent of 45? Can I do that? Sure. Opposite over adjacent. Almost lost it there. Opposite over adjacent is 1 over 1, which is just 1. So we don't write 1 over 1, just plain old 1. And then sine of 60. Do I need to draw a new triangle? No. Sine of 60, I can just come up to this one is, wait, we already did this, didn't we? Opposite hypotenuse. We already did that one. Lame. Something like that. We could do tangent, sine, cosine. So we're limited to these 2 triangles. I'm going to ask you a bunch of things. So you may be thinking, hey, why'd you put this graph up here? Well, remember when we were drawing angles in like this, like our reference angles and all that, and we said this is 30? We could draw our triangles here on this, and I'm going to show you why coming up. Is I could draw my triangle here and say, oh yeah, this is 1, 2, radical 3. And what I've done is, I think on yours, I've actually included like a little circle. Can I see that little circle? There it is. Dang, and I'm impressed. I nailed that perfectly. That's crazy. All right, so there's the triangle on yours. So I put this on there. You can draw that in there, or I could draw my 45. Check it out on there as well. It's going to overlap and get kind of crazy in here, but that's the 45, 45, 90 in there. And I could even put the 60 in there. So these little dots I included were the 30 degree, the 45 degree, and the 60 degree. So these are the exact values we can find. So we're kind of limited right now. Later on, we'll get more. I know you're excited for that. But for now, that's where we're limited. So why would I do that? Well, check it out. Let's try the sine of 210. So remember, this was 90 degrees. This was 180. So where's 210? Well, 270. So where's 210? Well, it's 30 degrees. Oh my gosh, that's kind of straight. It's 30 degrees past 180. So this angle here is 30 degrees. Well, why does that matter? Well, make up your sides again. Remember, the shortest side is 1. The longest side is twice that, and then the medium side is radical 3. But what are the signs here? So we have to be a little bit careful. This member is in the negative direction, so it's negative 3. This is negative 1. So if I actually want to find the sine of 210, I kind of have to draw it on this little thing with the little circle in there, just to make sure I'm in the right quadrant. So remember, this was the positive, positive, negative, positive, negative, negative, positive, negative. So 9.2 is coming back. Still, so 210, so I know if you just drew this, you can say the sine of 30 is really what? It's opposite over hypotenuse. It's just 1/2. But because it's negative over negative, it's actually negative 1/2 over 2. That 2, the hypotenuse is always positive. So because I'm in this quadrant, it's going to be a negative. Pretty cool. How about 300? Where's that going to fall? Well, there's 270. So 300 is going to fall right here. Whoopsh. So remember, this is what? This is 60 degrees below 360. Remember, all the way around is 300. So what's left over to make a circle? 60. If I make that a little triangle in here, I get this bad boy here. Now you have to be careful. Where is that middle side or short side? It's up here. It's 1. The medium side or long side is 2, and then this side is radical 3. So just so you know, this is like future stuff. Sorry, I should have prefaced that. This right side over here, not on the mastery check. We're going to focus all over here. But just so you can have it, and we're going to need it in chapter 10 anyway, it's kind of like a little teaser. Like, since we're talking about it, let's go ahead and talk about it. So don't freak out if this is killing you. Just make sure you can get the solid on the left side here. So if I put the signs in, I go over 1. And I go down to radical 3. So the cosine of this is what? Is going to be adjacent over hypotenuse. It's 1 over 2. And then I know my cosine is positive because I've got adjacent over hypotenuse. Is that pretty cool? While we're over here, can we do tangent? Sure, tangent of this triangle is going to be opposite over adjacent. So opposite over adjacent is going to be negative radical 3 over 1, which is just negative radical 3. So cool. And then the sine of 150. There's a lot going on. Can I erase some of this? I hope yours looks a little cleaner than mine. Let's just finish this out. But again, don't stress out about this. If you can draw a 150-degree angle, which I know you can because you just did it, remember, this is 150. So it's 30 degrees that's your little reference angle to get back to 180. So you've got a 30, 60, 90 triangle. And then you fill in the sides. This is 1. The long side's 2. And then the medium side's radical 3. So why is that so nice? Now find the sine. It's just opposite over hypotenuse, so it's 1 over 2. Are my negative signs right? You got to throw that in. I went over negative radical 3 up 1. Again, that's a lot. Might as well throw it at you, but just be cool with the left side, and you're gonna rock and roll on this one. All right, that's the same picture. Let's skip that. Okay, so we're pretty good at hopefully finding that. We're gonna introduce something else new here. And it's called radians, and hopefully you saw this in geometry. Maybe you did, maybe you didn't. Either way, what are radians? Don't freak out. It's just like, you know how sometimes we can measure like something in centimeters or we can measure in inches. You have a choice. If you like the metric system, which is really nice, or if you want to use the English system, you can use inches, or miles versus kilometers. Same kind of thing. We're so used to degrees, like we do everything in degrees. Like we just did it, 30 degrees, 40 degrees. We can convert to a thing called radians. So what is a radian? I'm going to tell you real quick. It's basically if this is the radius of my circle, so it's called r. It doesn't matter what it is. If I take this same distance r and I put it on the outside here of the circle. So if I go along, it's like an arc. I'm making an arc. That is also r long. Well, if I connect the end of that arc, this is also r because it's the radius. These are all the same. So this distance right here is called 1 radian. So this is 1. So your angle is actually a measure of 1. That is super weird. I shouldn't say weird. That is super different probably if you've never seen it. Don't freak out. So like if this was 5, you can measure up 5 on this, and this would also be 5. This is still a 1 radian. So it's 1 part of it. So that's maybe weird for you. So instead of picking numbers like 5, let's pick a great number to work with, which is 1. Radius of 1 is great. So if your radius of this thing is 1, let's think about this. What is a whole circle? The circumference of a circle is 2 pi r. So if I measure all the way around the circle, not just one part of it, if I go oh my goodness, oh, it looks like a heart. That does not look like a circle. But if I measure all the way around the circle, the whole circumference, it's 2 pi r, going all the way around the circle. So if I plug that into my formula, well, what is 2 pi r? If r is 1, it's 2 pi times 1, which is just 2 pi. So what does that mean? The whole circumference is 2 pi. And you're probably like, great, Mr. Brust. That's awesome. Well, what's cool about that? If that's 2 pi, what is half the circle? So it's just like saying a circle is 360 degrees. Well, I can say a circle is 2 pi. So if half the circle is 180 degrees, how much pi is that? Well, it's 1 pi. And then if I say half of 80 is 90 degrees, well, what is that? That is pi over 2. I cut the pi in half. So we're not going to really say radian of 1. It can happen, but we're really going to say radians are going to have pi in the answer. So it's a great way to measure based on circles and using pi. So it's really nice for radians for getting exact values in radians versus degrees. So if I want to do more than that, could I do a 30-degree angle? I mean, I know what 30 degrees looks like. Can I do it? Sure. What part of the circle is this? Well, I always think about 180. If 180 is pi, so 180 divided by what is 30? 180 divided by 6 is 30, so this is actually pi over 6. Holy cow, mind blown. Basically, for now, if you can memorize this, you're in business. 180 degrees is pi, so that is in degrees. This is in radians. Technically, we should put pi rad, but we just kind of assumed if you see pi, it's in radians. Holy cow, did I just blow your mind? I don't know. Let's try some. So if you're struggling with this, you can just say the key here is pi equals 180 degrees. Just like 2.54 centimeters is an inch, pi radians is 180 degrees. So if you're struggling here, put 180 in for pi. What is the sine of pi over 3? Well, it's like saying what is the sine of 180 over 3. So if you're converting to degrees, you can convert to degrees and say this is the same thing as the sine of 60. But at some point, I would like your brain to start thinking in terms of pi. So instead of thinking, hey, this is 180, this is actually pi, because the whole circle is 2 pi. So a 90-degree angle is pi over 2. And the more we do this, the easier it'll get. So if that's pi over 2, that's pi. This is going to be pi and a half, or 3/2 pi. Isn't that crazy? So the more practice, the easier this will get. So if I want the exact value of pi over 3, so if you can visualize the sine of 60, but really a third, this pi cut into thirds is going to be right here. This is pi over 3. Pretty crazy. So it's a third of 180, or a third of the pi. So if I go third, another third, I get to there. So what is the values here? So find your short side. This is 1. Your long side hypotenuse is 2. Your medium side is radical 3. So if you don't like that, you can just straight up draw your triangle, because I'm not going to give you anything out of the first quadrant. So you can say pi over 3 is the same thing as 60 degrees. Here's your little reference triangle. And I can just fill in the values. Short side's 1, long side's 2, medium side's radical 3. So what is the sine of 60? You just have to know the sine of 60 is the same thing as the sine of pi over 3. So if you want to convert to degrees, that's great. And then go ahead and plug and chug. What's the opposite over adjacent? It is radical 3 over 2. Awesome. Moving on. So same thing. Cosine of pi over 4. Any guesses what pi over 4 is? Well, pi over 4, remember, is just like saying 180 degrees divided by 4. So what is that? It's 45 degrees. So check it out. It is the 45, 45, 90. Or instead of 45, 45, 90, you can think of it as the pi over 4, pi over 4, pi over 2. Kind of crazy, but it's the same thing. It's a 1, 1, radical 2. So pi over 4 is 45 degrees. I want the cosine, so that'll be the adjacent. This is going to be 1 over radical 2. But can't leave that radical on the bottom. So to get rid of it, times it by itself. In this one, you'll probably go, after a while, you'll realize I keep running into this number. I'm just going to go straight to cut out the middleman and do that bad boy right there. All right, so can we do tangent of pi over 4? Sure, we can use that same 45, 45, 90 and just say what? Opposite over adjacent. I love this one. It's just 1 over 1, which is just 1. Fantastic. And then the sine of pi over 6. So if the pi over 3 is 60 degrees, any guesses what this is? Yeah, it's the same thing as saying what's the sine of 30 degrees. So if you have to convert it to degrees, 180 divided by 6 is 30. But I'm hoping you'll start thinking about that as a sixth of pi, a sixth of this circle to here. Awesome. Just to finish out, I'm going to use the same thing. The sine of 30 is opposite over hypotenuse, so it's just 1 over 2. Fantastic. So I won't give you anything above 90 degrees, so you don't have to worry about these other quadrants for now. But it's the same numbers, just different signs. Excellent. So just to make sure we're cool, now that we have degrees and radians. So what if I want to put this and find the approximate? So back to the approximate, back to the beginning here. If I want to say what is the sine of this, you don't have to convert or anything. Clear this out. You just have to make sure you're in the right mode. So check it out. Right next to the blue button's the mode. Go to mode, and you need to change. Right now you're in degrees. So I need to switch over to radians. So make sure radians highlighted, hit enter. Now I'm in radians. So now I can just type in the sine of pi over 3, Where's that pi button? It's right above the exponent, the caret button in blue. So if it's in blue, I got to hit second caret. Divide that bad boy by 3. And it's going to tell me the answer. So check it out. We knew that one. That's the sine of 60 degrees, which is approximately 0.866. So it's approximately this. That's the approximate value. Awesome. So what happens if now you're back in degrees and you want to go 32 degrees? There should always be a degree sign here to make sure you know you're in degrees. And I want to type that in. Be careful, because if you just go, hey, cosine of 32, going to type that in, and I get 0.834, you're like, oh, that looks pretty good. Check it out. It's not right because you're in the wrong mode. You got to change your mode back to degrees. So you have to make sure that you're in degrees, because that was doing 32 radians. Totally different. So now do the cosine of 32. What's the cosine of 32? It's 0.84. So those were actually really close. Normally it's like drastically different. So it's 0.848. So I can type in and get the approximate. So make sure if you're in degrees, you're in degrees. Usually you'll get a weird answer like, what? How about this? Now I got to go back to radians. So if I want tangent of pi over 7, so I couldn't do the exact value of this. This is the only one I could do the exact value of. Here's pi over 7. I have no idea what that's going to be. Just make sure your mode's right. So take your mode, toggle back to radians. Love to toggle. Toggle all day long. Toggle pi over 7. So I'm going to put pi over 7. The whole reason I do this is to make you switch modes. And I'm going to make you do in the practice, switch modes. So it's 0.481. I'm feeling kind of lazy. I'm just going to drag it over. There it is. It's 0.481. So that's the approximate value of the tangent of pi over 7.48157, blah, blah, blah. Awesome. So you can use your calculator for approximate. That is the main chunk of this thing. That's going to be the match trick. That's going to be the practice, is doing all those things. I'm going to kind of tie it together real quick to this unit circle idea, because it's coming up chapter 10, and we're going to need it at some point, so we're going to kind of address it now. So what is a unit circle? You're going to see this for a lot. It's going to be a circle with radius 1. Why 1? 1 is so great to work with. And all we're going to do, and we've kind of started, is we're going to put these special places on there. So this 30, 60, 90 triangle, a 30-degree angle like this, if it has a radius of 1, that means the hypotenuse is 1. Well, if the hypotenuse is 1, what is the short side? Well, the short side is going to be half that, so it's going to be 1/2. And then what is this side going to be? It's going to be 1/2 times radical 3, or radical 3 over 2. So it's the same rules, but we're going to start looking at this point. This point is going to be the coordinate point. I can go over what? I can go over radical 3 over 2, and I can go up 1/2. That is awesome. So that's an exact point on this unit circle. This is going to really help us, because we're going to start trying to graph these trig functions, and we're going to need all these. So if I do 45 degrees, draw my little triangle in here. Same thing. What's the radius? The radius is 1. That's the whole idea of a unit circle. Well, in this is a little bit different. This side is going to be 1 divided by radical 2. If I clean that up, what do I get? I get radical 2 over 2. So we've already seen that number. So this side's radical 2 over 2. This side is also radical 2 over 2. So what are the coordinates of this point? It would be over radical 2 over 2, radical 2 over 2. I love 45 because they're both the same. So this is like your x comma y. These are points on the graph. And then if I do 60, same thing, the last triangle I know. That's why I had these 3 dots, these exact values. That's kind of why they're so important. 60 is the same thing as 30. It's just flip-flopped, isn't it? So I know the radius has got to be 1. It's a unit circle. So what is this? The short side is 1/2. The other side is 1/2 times radical 3. And these coordinates are the same, but you're over x. You're 1/2. You're up radical 3 over 2. Huge, huge, huge important. So what else comes from this? Well, we can actually find this point where I couldn't before. I can't draw a triangle there. It'd be like a straight line, wouldn't it? Up and down. But if the radius is 1, what are the coordinates of this point? You go over 0, up 1. So we actually now know what? We can actually now find the exact value of these coordinates right here and right here. So what is this point? If the radius is 1, this point is over 1, up or down 0. If I come down here, this is over 0, down 1. And if I go straight right, this is a kind of, I guess, flat triangle. That's really weird. Over 1, up 0. But I can find the exact values of it. So if I want to find the sine of 90 degrees now, well, the sine of 90 degrees, you can't, it's weird. You couldn't do that in your triangle. But if I look at this, if you check it out, what are these things? Well, what is the x value and the y value? If I look at this, if I look at 30 degrees here, 30, this opposite over adjacent, Opposite over adjacent is what, sine? The sine of 30 is 1/2 over 1. That's why we picked unit circle, which is just this 1/2. So that means the sine of 30, the y value is actually your sine. The x value is actually your cosine. That's the radical 3 over 2. So that's huge for this. X is cosine, y is sine. So if I want the sine of 90, what do I get? It is 1. Let's do another one of these before we press on here. What is the cosine of 180? So cosine of 180, well, this is 180. Boom. What's the cosine value? It's the x value. Cosine is x, so it's -1. Isn't that super cool? How about the sine of pi? I'll throw some radians at you, mix it up a little bit. Well, 180 is pi. What's the sine value here? It's just 0. Boom. Good luck on the math check. Peace out.